Hello, and welcome to Solving Client Connectivity Conundrums, part of our Setting Up for Success with Exchange Online series. I'm Jason Slaughter, and one of my favorite subjects is connectivity. Client connectivity cases can often be very complex, and this can keep life interesting, but from ActiveSync to web services, there's often confusion on where to start troubleshooting, what tools to use, and how to connect the dots when things go wrong. In this session, I'll try to clear up some of that confusion by using some common issues to illustrate how a Microsoft engineer like me follows the data to drive case resolution. Then, I'll quickly go over setting up Fiddler, a valuable tool we'll be using to dig into our web traffic. Lastly, we'll go into the scenarios. Now, this is a level 300 session, so the scenarios aren't meant as a troubleshooting guide for a particular problem. I'm making some assumptions here that you're already familiar with how clients are supposed to connect, how Exchange works in general, and how these web-based protocols work. The scenario is just some background to help tie the processes together. Throughout this session, I'll try to call out any tips or tricks I use to get through my day more efficiently. So, how do we do it? I'm not going to go deep into troubleshooting methodology here, such as avoiding anchoring or creating a troubleshooting matrix, but instead I'll go over the general approach we take when starting our investigation. First, we scope the issue with our customer. This process is similar to the 5 W's a lot of you are already familiar with. It's the who, what, when, where, and why of an issue. The answers to these questions will help define the issue, and we'll begin narrowing down where we need to initially focus our efforts. The more detail we have here, the more narrow the scope. Next, we break down the problem even further by asking ourselves questions. Where is the most likely place we'll find the issue, and what's the most probable solution based on our own experience and assumptions? What can we rule out immediately, or rule out with a few simple tests? A lot of cases are quickly broken down into client, network, and server-side categories, but each case is different, and you'll want to think about the broad categories that would apply to your specific issue. Simple tests would be things like trying a different client on the same network, or trying the same client on a different network. Again, this is just a high-level overview of our process, but I think you get the idea. We also make sure we understand how the product is supposed to work in a given scenario. Sometimes we already have this knowledge and there's nothing more for us to do here. But each customer we work with has a different environment, and it's important for us to understand how those differences can affect the product's behavior. So we often build labs or work in a test tenant to try to reproduce the issue in test configuration changes. There's also lots of information in our public blogs, videos, and documentation, and I encourage you to take advantage of these great free resources. It's important to understand this is often an iterative process, and this isn't an all-encompassing list of the things we do during an investigation, but it's a good foundation to start with. Okay, let's go over what Fiddler is and the initial setup. Fiddler is a web debugging proxy, meaning clients connect to it instead of the desired endpoint, and Fiddler passes those requests and responses back and forth. In the middle of this process, Fiddler is decrypting the traffic if needed and letting us see and analyze it using a set of inspectors. Normally, Fiddler will run on the client you're wanting to capture. It'll take over as the system proxy so that all web requests are sent to the Fiddler application instead, where Fiddler will generate a certificate for the URL being requested. It'll use that for all encryption with the client and then connect to the requested server as if it were the client itself. Because Fiddler sits in the middle and has access to the unencrypted streams on both sides, we can use it to see the full request and response data and analyze it. To make life easier, Fiddler has a plugin system, and there are a number of plugins that have been written to help us analyze traffic more efficiently. There are inspectors for Exchange ActiveSync, Mappy over HTTP, Windows Communication Foundation, and more. For this session, we're only going to be using the built-in inspectors, such as the ones for viewing headers and XML. Let's quickly go through the initial setup of Fiddler so it's ready to use. When running Fiddler for the first time, go to Tools, Options, and click the HTTPS tab. By default, the decrypt HTTPS traffic checkbox is unchecked, meaning Fiddler will not try to decrypt encrypted traffic. All the traffic to and from EXO is encrypted though, so we'll need to check the decrypt box. When you do this, Fiddler will create a self-signed certificate to use for all traffic decryption, and the system will need to trust it. Windows will ask for confirmation through a series of dialogues, so I'm going to click through to confirm here. Over on the Connections tab, the Act as System Proxy on Startup is checked by default. This means when Fiddler starts, it'll tell Windows to use itself as the proxy for the system. This will work for most scenarios, and apps like Outlook and most web browsers will honor this setting. For capturing external connections, like a mobile device, you'll need to check the Allow Remote Computers to Connect checkbox. There's more to it to get this working, and I've put a link at the end of the presentation that'll walk you through that process. Lastly, if you already have a system proxy and you need Fiddler to use that, click on the Gateway tab and configure your proxy there. I'll click OK here and we're ready to capture. Notice down in the bottom left of the window, Fiddler lets us know that it's capturing. That area is also a shortcut. You can click that area to start and stop capturing. Okay, with our Fiddler setup out of the way, let's jump right into a scenario. One of the topics that pops up a lot is auth prompts. Authentication cases can be tricky, especially if you've got a lot of moving parts where it's not as simple as sending basic auth in the header. In this first scenario, we've got end users trying to use Outlook to connect to Exchange Online, but unable to log in. We've gone through our scoping and determined that only our Outlook 2013 clients are affected, and Outlook 2016 and OWA work just fine. This tells us we can probably set any AD concerns on the back burner. We know that this was working fine last week, so there may have been some changes over the weekend, but we don't know what they were. We'll want to keep this in mind when thinking of possible causes. Lastly, it seems to affect all regions in the same way, so for now we probably don't need to dig into networking issues between the sites. We do some testing and find we can reproduce the issue with a new test user on 2013. This is an important find. If we can reproduce the issue on demand, we can more quickly iterate and test our hypotheses. Let's load Outlook and see what we're dealing with. We're getting an immediate pop-up. I'll type my password and see what happens. Another prompt. I'll try one more time just to be sure. Nope, another auth prompt. We knew this would happen, but now that we're able to see it ourselves, we can verify that we're on the same page with our customer. Remember, this is affecting multiple users, so it's unlikely that this is an actual bad password, at least in the traditional sense. So resetting their password isn't going to be useful here, but perhaps checking that the user hasn't become locked out is. While testing, it's important that we don't narrow our view so much that we forget that other problems can be cropping up in the background. Okay, let's see what's going on behind the scenes. Here, I've loaded up Fiddler and notice it's capturing, and I have it filtering on the Outlook process to reduce the amount of noise in the trace. Here's the prompt again, and I'll type the password in a couple times to see what's captured. Let's see what we have here. Okay, it looks like Outlook is at least attempting to auth. I can see by this authentication header we're using basic auth, and the server is responding with an empty basic response header and a 401 response code. By the way, you can use the built-in auth inspector to make it easier to find auth-related headers. Let's compare this with a Fiddler trace of a working Outlook 2016 client connected to the same mailbox. Okay, I'm going to go ahead and connect my Outlook client and whoa, that's a lot of requests. I'll stop the capture and we can already see that we've got a lot of 200s in this result column. Previously, we were getting 401s. Clicking on a session brings up the details, and here we can see that Outlook has sent a bearer token, meaning it's using modern auth instead of the basic legacy auth we saw from the Outlook 2013 client. The next step here varies. But a good next step is to spot check additional Outlook 2013 clients to see if they too are only using legacy authentication. If so, we have a pattern and we'll need to investigate things like our Exchange auth policies, whether Azure Active Directory security defaults have been enabled, and what our clients support. In this case, our investigation would find that many users are moving away from legacy auth. Blocking basic authentication can help protect your Exchange organization from brute force or password spray attacks, whether you're online or on premises. Our users' security team implemented such a policy, but only Outlook 2016 and higher support modern authentication out of the box. This is why Outlook 2013 was unable to authenticate. It was only using basic auth. EXO blocks basic auth in a specialized way to prevent harvesting and account lockouts, so Outlook 2016 was able to continue to log in even though we have a lot of failed Outlook 2013 logins. All is not lost for our customer, however. Outlook 2013 does support modern auth, but you'll need a registry key to enable it. I'll have links to more information at the end of the presentation, and I urge you to check them out. We plan to begin disabling basic authentication in existing tenants with no recorded usage as early as October 2020. We'll provide notifications via Message Center posts before we do that for any tenant, but you should be preparing now. Okay, let's move on to a slightly more complex issue, hybrid FreeBusy lookup. So in this scenario, we've got end users trying to create meetings that include on-premises mailboxes. When they check availability for those users, they get hash marks instead of FreeBusy information. We've gone through our scoping and determined that this does indeed only affect lookups for on-premises mailboxes. Only our Exchange Online users are affected, and the issue seems to affect all versions of Outlook and OWA. We do some testing, and just like last time, we can reproduce the issue on demand with the test user. Let's create a meeting with our cloud user and include an on-premises mailbox. I'll click the scheduling assistant to verify availability and hash marks. Hash marks, of course, means there's no availability information, and that's, well, bad. Before we move on, there's a bit of data that we can gather right here. If we hover on the hash marks, we might get a useful clue. There are a few messages we might get here, like this one. This tooltip says the external recipient server could not be determined, which probably points to some issues with AutoDiscover, as that's what it's for. For our scenario, the tooltip says the recipient server could not be contacted, which indicates some type of connectivity issue getting to the endpoint. Let's take a look at a Fiddler so we can try to see what's going on. Okay, here's the FreeBusy request, and we can see the get user availability request command here in the XML. And let me minimize this time zone information, and we can see that this is for user 1, the on-premises mailbox. By the way, this tree view is just part of the XML inspector built in the Fiddler, and it makes reviewing EWS calls much easier. Okay, I'm going to expand this window so I can see better. And there's an exception here. I can also see the name of the server that threw the exception. This isn't one of mine. This is a cloud server. I'll scroll over to get a better view of that web exception. It looks like we've got an SSL problem, but the rest of that error is cut off. I'll right-click here and send this to the built-in text wizard. Perfect. I can see the entire error now. The remote certificate is invalid. Let's take a closer look at that certificate. Unfortunately, the error message we saw in the Fiddler didn't tell us which on-premises server has a certificate issue. So you may have to do some legwork to determine which servers have which certificates. In this lab, we've only got one server, so it'll be a bit easier for me, but the steps to check out the certificate are the same regardless of the number of servers you have. Okay, let's first verify where EXO is going for FreeBusy information for on-premises mailboxes. I've got Windows Terminal open here, and I'll use the EXO PowerShell v2 module to connect to my tenant using Connect-Exchange Online. The Modern Auth pop-up happens off screen, and the first thing I'll check is the intra-organization configuration to see how our on-premises domain is defined. Here, we can see the hybrid domain, exechlab.com. Next, I'll check the intra-org connector, or IOC, for that domain to see the actual endpoint the cloud is using. This target sharing EPR setting is valid for my org, but it's always a good idea to double check. Note that by default we'll only have a discovery endpoint here, and the cloud will use autodiscover to find the EWS endpoint for FreeBusy. I'm overriding that with the target sharing EPR setting so that I can force some behaviors in this lab. Note that depending on when you configured hybrid, you may not have an IOC, and you would instead check the organization relationship. You'll have an IOC if you went hybrid after 2013 CU5, and the IOC is OAuth enabled versus the organization relationship only supporting DAuth. Notice that just like the IOC, there are separate URL properties for both discovery and sharing. Now that we know where the cloud is trying to connect on premises, I'll copy the target sharing EPR out of my IOC so that we can test it in a browser and avoid any mistakes. Okay, I've opened my Edge browser and I'm just going to go straight to OWA and check the certificate. I'll click the lock icon here next to the address and select the certificate from the dropdown. Here, I can see if we're using the correct certificate. This shows the cert was issued to exechlab.com, and I can see that we're within the validity period and it's issued by a third-party CA. If I click the certification path tab, I can check the entire cert chain, and as you can see, Windows considers each of these OK. There are other things we can check, like the CRILs and TLS 1.2 support, but I think I see the problem. Have any of you noticed the problem yet? Let's see if the next step gives you the clue you need. To make sure that we don't have any typos or other mistakes in our test, I'll use the copied URL from the Exchange Online shell and paste it in the address bar. Now, this is an interesting result, and we might be able to find something online about this error message. I'm going to click Advanced here to get a bit more info. Do you see the issue now? The browser is complaining that exechlab.com doesn't match star.exechlab.com. A wildcard certificate expects a subdomain, and normally the root domain will be added as the subject alternative name in the cert if the root domain needs to be secured by the same cert. I'm not going to recreate my certificate, so let's just change the target sharing EPR on our IOC to resolve this one. There. I've changed the URL EXO uses to connect to EWS on premises, and that URL will match my cert. Let's test and make sure it's working. I'll create another test meeting, add my on-premises mailbox, click the scheduling tab, and there we have it, availability data. Our last scenario is a classic but complex issue, OA JavaScript errors. In this scenario, we've got end users unable to log into OA. After scoping, this is what we find. There seems to be no pattern to which users are affected. The error message is similar, but not the same across affected users. And using a different browser sometimes changes the behavior, but not always. Due to these odd factors, we cannot reliably repro in a lab, but we've got access to an affected user, so let's take a look. I'll open OA so we can see the behavior ourselves. There it is. We're immediately getting this pop-up error. We can see it's some kind of JavaScript error, and I'll copy this line out for reference. Then I'll dismiss this window and see if that's affecting anything. Looks like I can't open any messages, but I can change folders. Well, sort of. I can't really do much here with that error. A lot of JavaScript files are referenced in this new window, but I can't really make sense of it yet. We need to get a look at that file, so I'm going to hit F12 here to bring up the browser DevTools and click the Networking tab. I'll refresh OA, and that'll capture the JavaScript file being loaded, even if it's cached in the browser. Fiddler can't do that. Here's the error again, so I'll pull the file name out of the error and filter the capture. Now that all the noise from the reload is filtered out, we can see that we have a 200 response code and the file was being pulled from cache. Just like in Fiddler, clicking a session will pull up more info. I don't think you need to be a developer to see that this file isn't JavaScript and is instead corrupt data. Looking at the headers, we can see where this is being loaded from, and this is the expected endpoint. There are lots of headers being returned here, and there will normally be a header showing the front and back end servers. This is useful to see where the front end proxied the request. Let's grab the full URL for the JavaScript file and open it directly in the browser. This looks like the same corrupted data we saw before. Since we're not using server names for the request, we may be going through another device. This browser is on the internal network, and I may be able to bypass any other devices by using the actual server name. Sometimes a host file is needed, or the test may need to be carried out on the server itself. Let's replace mail.exechlab.com with the server name and see what happens. Well, this is more like it. It's pretty clear there's a difference between this file and what we see when using the public namespace. Investigating the IIS logs would show no request for this file, and comparing the physical file on the drive would show it's identical to the file when browsing the server name. The evidence points to something in between the mail.exechlab.com endpoint and the server. Did you happen to catch the clue that was in the response headers? It was fast, so don't feel bad if you didn't. It was here. The x-backend-begin response header tells the client when the request to the backend server started. It's mainly there to help with diagnosing performance issues, and it's a calculated field. The date here being nearly 5 months before the real request is a dead giveaway that something's caching where it shouldn't. As with all these scenarios, they're based on real cases, and in this case, the issue was caused by a big load balancer with an overzealous caching profile, along with some untimely browser caching. Connectivity issues are one of our top call drivers, and there seems to be an endless variety of scenarios and causes. I hope that if you do have an Exchange-related connectivity issue in the future, you can put some of this info to good use. Don't forget, the end of the slide deck has links to important information regarding basic authentication deprecation, in-depth Fiddler setup, and more. I'm Jason Slaughter. Thank you so much for watching my session.